When trying to study an electrical circuit, no matter what type of electrical circuit or more intricate electronic circuit, it's going to be more convenient to use what we call schematics as opposed to trying to make an actual drawing of the circuit components. For example, here we have an image of a circuit made up of a battery and a parallel plate capacitor. So instead of trying to draw something like that, the schematic is going to look more like this one here. We represent the capacitor, the parallel plate capacitor, by two lines of equal length. Now the battery, we represent it with two lines of unequal length. The smaller one of the lines is going to represent the negative lead of the battery. The larger one is going to represent the positive lead. The connecting wires between the capacitor and the battery are going to be represented by straight lines. Normally we do a straight line, not something like this. Actual wires might look like this, but normally in a graphic we're going to draw it in straight lines. Here are some symbols for a capacitor, for a battery. For a capacitor, sometimes we are going to have it look like this. Instead of having them parallel to represent other capacitors where they are not necessarily parallel plates like electrolytic capacitors, usually we do something like this. And for a battery, sometimes trying to represent that we have multiple cells, so instead of having it just like that, we might have 2 or 3 series of small and large bars. And this is a representation of an electrical switch. In this particular case, the switch is open. If it were closed, this end here would be touching this end. The wires, when we have wires in an electrical circuit, under static conditions, those wires are going to be at the same voltage or the same electrical potential. So for example, here what I highlighted in yellow, all of them are going to have the same electrical potential. Let's say if I had a 9-volt battery and I kind of set this to 0 and then set this to 9 volts, since it's a 9-volt battery, the difference is going to be 9 volts. So if I decide, or if I set this to 0, the other one would be 9. If I set this to 1, the other one would be 10, etc. So all what's in yellow is going to be at 0 volts. I'm going to try to highlight the other side. Okay, let me use another color. So everything here, the green, is going to be also at the same voltage, but in this case, it's going to be 9 volts. So in an electrical circuit, whenever we have lines without any device in between, those lines are going to be at the same voltage. Now here is an example of a battery where we see the different cells. A battery in an electrical circuit is going to maintain a constant potential difference. 9 volts, 6 volts, whatever is that battery. That's not necessarily constant power, and we'll talk about electrical power later on. And it's not necessarily constant current either, and we'll see the relationship later on. Now, what a battery does is not really producing charges. Actually, charges, the number of charges never changes. You just move charges. And that's what the battery does. It's going to push charges into the circuit. And whatever charge enters the circuit, whatever negative charge enters the circuit from the negative lead, is going to correspond to a negative charge entering the battery from the positive lead to allow the battery to complete the chemical reaction that happens within the battery.